Hello YouTube family, welcome back to the channel. My name is Mriganka Das and today we are going to perform one of the most exciting data visualization in our program, a 3D PCA plot, but with a twist. We are going to apply it to something everyone loves, it's cricket. And in India, it also known as the sports religion of the people. Okay, so let's proceed with the video. In this video, we will generate a dataset of 100 cricket players, analyze their performance across multiple matrices, run a principal component analysis that is PCA, create a stunning interactive 3D PCA visualization, understand what each principal component PC represents, and finally learn how the same method can be applied to biological sciences like genomics, proteomics, and drug discovery. But the best part is I'm not just showing you the plot. I'm going to dissect every command, explain every parameter, and break things down so clearly that even you have never used PCA before, you will walk away like a pro. And trust me, the 3D plot we will build today is so beautiful that your R program might ask just for a coffee break. All right, let's dive straight into the code and unlock the magic of PCA. So I'm using the R version of 4.5.2, which is the latest version of R. And here, this is the console of the R, and this is the script. We can generate this script from file. We can click here to the new script, then the script will appear. Before that, the script will not appear. You have to do this. Okay. So before we can analyze anything, we need tools. So the tools I am using for this are Plotly, Deployer, and R Color Brewer. Okay, so I prefer this R version for R Studio because it's clean and I like clean versions. So it's my preference. You can choose. You can also use R Studio for more cleaner, or if you are comfortable with R Studio, then you can use it. And I use this version. So the Plotly package creates interactive 3D plots, allows clicking, zooming, and rotating. Okay. Deployer used for manipulating the data, selecting columns, filtering, etc. And the R color brewer gives us beautiful color palettes of our points. So if you don't have, I already told that you can install it by this command. Okay. And for using it in the R package, we need library, we need to recall it. So for recalling the packages, you need this command library. Okay, you can put the package name inside first bracket. Okay, and then close it. If you run it, I will run the all the recalls together. If you run it, okay, this will show like this, and the R software has successfully recalled it. Okay, so next is we will make our data frame. Okay, we'll create the data frame with 100 cricket players. So this is df is equal to data frame. This we can also use equal to here if you want to, but I prefer this. Okay, so I will specify each components to if what data I want to create. So we build a data set from scratch from this. Okay, so this data frame creates a table, and this page zero command creates the player name from player 1 to 100. This 1 is to 100 is it creates the data of 1 to 100. Okay, and generates the player names from 1 to player 100, and run this run if command. Okay, run if command gives random numbers between minimum and maximum. So perfect for it is perfect for continuous cricket matrices like average and strike rates. And this sample command gives picks random whole number, perfect for wide wickets and runs. And the result is realistic data set resembling IPL or ODI cricket player stats. Okay, so uh, if you have a already in data frame, that data or in CSV file, as a CSV file, you can directly recall it using the read.csv file in double asterisk. You can call it, and you can call the file, and you can save the file in the documents, so that R automatically recalls it here. Okay, so I am generating a data, so this is my data. Okay, so I will run the code now. Okay, the R has successfully run in the R has successfully run the code. So now, and I want to see what type of data is I have generated. So I can use the head df command. Okay, this prints the top 6 rows. It is a quick sanity check before deeper analysis. Okay, so let me click the run button. See, this is this is my table. See, player 1, player 2, player 3, player 4, player 5, player 6, and these are my uh, column names: batting average, bowling economy, strike rate, bowling strike rate, batting strike rate, boundary percentage, dot ball percentage, wicket taken, runs conceded. So against this player name, these are the columns, and these are the stats that the R has generated using this command. Okay, so I can see by using this head df command. Now I will prepare the data for my PCA plot. Okay, so part 5 in our uh, video is creating the PCA plot, which is the theme of our video. Okay, so so this is the command PCA res, PCA underscore res. Okay, R is, I had to highlight one thing before everyone, that R is highly case sensitive. So and also space sensitive. So we use underscore if we want, if you want space in the in between two words. Okay, so so this is the command for PCA underscore res equal to prcomp df underscore numeric comma scale dot true. Okay, so this performs the PCA, and scale.true equal to true standardizes all variables. This ensures that large valued variables like runs considered do not dominate smaller valued ones like economy rate. Okay, so PCA compresses our 9 variables into coordinate systems, and PCA dollar regs okay, PCA regs returns the transformed values into PCA1, PCA2, PCA3 up to PCA9. Okay, so adding back the player name, let us label each point uniquely in the plot. For creating this, we need to assign the color palette. Okay, okay. Before that, we will do this, and we'll assign the unique colors to that. So color palette, uh, this command color palette. Before that, we run it. We'll run the plots. I will run the command. Let's run the command. Okay, this R has successfully run the command. Now I will assign unique color palettes to 100 players. So color palette equal to color ramp palette. In the in the first bracket, we will write brewer.pal and this command. Okay, so brewer.pal 12 20 paired gives us 12 aesthetically matched colors. Okay, and color ramp palette stretches this 12 into 100 smooth colors. Now every player gets a unique color, making a plot gorgeous, making the plot very gorgeous. Okay, when I generate, you will see that the plot is very gorgeous, and like it's stunning to see such beautiful plot in a data set where it is in like numbers and in .csv file. Okay, so I'm very intrigued with this method and this visualization. So you can also have my excitement in the video. So hoping it will understand it easily and apply it in your uh, studies, okay, in your data visualization technique. So after assigning the colors, let's build a interactive 3D PCA plot. Okay, so we have run the we have run up to this. Okay, now I will run the this command for assigning the color palette to every pair, every cricketer. Okay, then I will start the interactive 3D plot, 3D PCA plot. So for this we need this command. Now I need to assign it. Okay, so the type 3D scatter 3D, this scatter 3D, we create a 3D scatter plot, and also we'll assign the access to each PCA component. Okay, PCA component means principal component. So x-axis will be PCA PC1, y will be PC2, and z will be PC3. Okay, so these are our PCA access, and the color for each player name, each player gets a color for our palette. And the marker list, okay, this is the marker list. Marker list signifies the size 6 equal to 6 makes the points visible but not too big. Okay, and opacity of 0.92 gives a soft transparent glow. This line alone generates the 3D code 3D visualization. Okay, I will run the interactive 3D plot now. Let us run it. Okay, the R has successfully run it, and let us delve into the next part, which is customizing the title and legend axis. Okay, legend and axis. For this, I'll be using this command. This is the command. Okay, so so the layout allows so the layout allows us to do what? Allows us to beautify the plot. Okay, and the title $x, the title $y of value of 0.9, that is 0.9. Okay, it lowers the title slightly downward. Okay, if we like it is the value is higher, then it will be upward, this title will be upward and will be not able to generate anything. So it is not visually correct or standing. Okay, so we don't have the um, title in our space that we want. So this is the perfect number that we can create with the title. Okay, then the legend is placed neatly on the right, and axis levels tells us which principal component we are viewing. Okay, so let me run the command now. Okay, the R has successfully run the command now, and finally we'll do what? We'll give the command fig, that it generates the figure, so that it generates the figure. Okay, I will run the command. The R has successfully generated the command. Okay, so this is the 3D PCA plot. So this is the 3D PCA plot that we have generated using the R command. And now just let's decode, okay, it. So because this is the part of everyone ignores, but it's the most true power of PCA. Okay, principal component analysis. So the PC1, this component, PC1 captures the strongest pattern in the entire dataset. For cricket, PC1 typically represents higher betting strike rates, higher boundary percentage, and low dot ball. Okay, and so the players with high PC1 value are strong batters, economical bowlers, and consistent all-rounders. So players with low PCA value, okay, players with low PCA value such as this, Okay, players' low PCA value less consistent with the bat and with dot balls. Okay, and have high economy rate. And also now we'll explain the PCA2. Sorry, PC2. It's the bowling dominance axis. From analyzing this component, we can have the knowledge of which player has the highest bowling dominance axis. Okay. So PC2 usually captures the second most important pattern independent of PC1. In cricket, PC2 tends to reflect the wicket taken, bowling strike rate, and runs considered bowling economy impact. Okay, so high PC2 players impact bowlers, match changers, etc. And low PC players are part-time bowlers and betting oriented players. Okay, so from PC2 we can have the knowledge of these components. And PC3, this is PC3. PC3, from this we can have the knowledge of pressure and efficiency axis. Okay, PC3 often captures the subtle relationship like ability to maintain the strike rate under pressure, balance between boundary percentage and dot ball percentage, bowling efficiency versus batting explosiveness. Okay, a high PC3 value may be a power hitter, someone who scores boundaries but rotates strike well, a bowler who performs better in crunch moments. A low PC3 may signify that the player struggles with strike rotation, concede too many dot balls, and perform inconsistent under match pressure. Okay, so these are the dots that signifies each players, and from this dot we can have the x-axis value, y-axis value, and z-axis value, and also it will show the player name. Okay, we can see that this player, this green dot is player 32, and from this if we go to player 32 we can see that this color signifies it, and if we give click on it, the player 32 disappears. So from this we can identify the each players from it. Okay, this is the player 32. See, it disappears then appears after clicking. So from this we can have the knowledge of and we can see, we can create, also we can create the large data set into smaller single plot. Okay, smaller single plot. So this falls under the multivariate analysis, and I have explained in the earlier videos how it looks like and what can be done and what are the benefits of it. Also in this video I will explain the benefits of it, like what are the bonuses if we can we can use. Okay, so now here is the mind-blowing part. The same PCA method you just applied in the cricket players is used in gene expression studies, metabolomic heat maps, drug discovery, microbiome diversity, cancer studies, and many other biological dataset you want to showcase. Okay, in via the R program. Okay, so PCA helps the biologist reduce, like if you have 20,000 genes, it can reduce to 2 or 3 components. If you have 500 metabolites, secondary metabolites, you can have meaningful clusters and like 100 drug toxicity parameters. If you have parameters for, like if you're searching for your compound and you have 100 drug toxicity parameters, you can visualize it in one plot, that is PCA. Okay, the PCA divides up each variables into 2 or 3 components. So whether it's cricket or biological dataset, PCA reveals hidden structures and turns complicated datasets into simple, beautiful insights. Okay, so you have learned something new today. If this plot impressed you, or if you simply love cricket and data science, smash the like button, comment your favorite cricketer's name, and share this video with your fellow analysts. Okay, and for other biological dataset, if you want to perform PCA for biological datasets, 2D PCA, 3D PCA, heat maps, so you comment down below in the comment section. Okay, so this is Mriganko signing off, and I will see you in the next video where science meets simplicity and learning becomes effortless. Thank you so much for your patience, and don't forget to subscribe and share it with your friends. Okay, bye bye.